Welcome back to part 2 of your final exam review, graph analysis. Okay, everybody, please take out your science notebook. Pull it open to page 35 or whatever page number you're on. Open up to page whatever, and let's do some work. Okay, so as you are pulling out your science notebook, we are going to take a look at our final exam review. So let's start by opening up number 2 for the motion graphs. And we are going to start on slide 21. So scroll down to slide 21 out of 64. And we've got a graph that looks like this. Okay, so as we are working, we're going to try to figure out what's going on at various points of time. So first, as we look at this graph, the most important thing to figure out is to figure out what is being shown here. So let's start by looking at the axes. I see this is a displacement versus time graph, indicating how far they've gone over what period of time. So displacement would be how far they have gone. Time obviously is in seconds. So that's 1 second, 2 seconds, 3 seconds, 4 seconds, all the way up to 6.5 seconds. It's listed there. Displacement is in meters, and it looks like it goes from -10. So the blue car starts at -10. The black car starts at 0, and it goes up to 40 at the top, but nobody ever gets to 40 meters. Okay. So let's look at the question. What is happening for both cars in the first second of the graph in terms of displacement, in terms of velocity, in terms of acceleration? All right, so blue car and black car in the very first second of the graph, that would be up to, oops, where are we? There we go. So that would be up to this point right here. Nope, not that point. This point right here. There we go. That is second 1. So up till there, what is happening? So I noticed that both cars, so let's talk with black car. Black car goes from 0 to 10 meters. The blue car goes from -10 to 0 meters. So both cars move forwards by 10 meters. And it also looks like the black car is always ahead. It's up here. See, so it's up here, which is 10 meters ahead. All right, so it's up right there. That is 10 meters further along than there. And that's true here too. And here it was at 0 instead of at -10, which is still 10 meters ahead. So the black car is in the lead by 10 meters. And in the first second, both cars move forwards by 10 meters. So let's type that in. So moves forwards by 10 meters. Black car is the same. Moves forwards 10 meters. And the one that's in front, I'll just double check, is the black car. Okay, so the black car is 10 meters ahead of blue car the entire time. All right. Now, in terms of velocity during that time, checking on the graph, I noticed that the velocity is the slope of the displacement. So it moves 10 meters in 1 second. 10 meters per 1 second is 10 meters per second. So the velocity is positive, and it would be 10 meters per second. And the black car is the exact same, 10 meters per second, because it goes 10 meters divided by 1 second, divided by 1 second equals 10 meters per second. And then the acceleration. So the acceleration would be the change of the velocity. In this case, it's a straight line. So is the velocity changing at all? It's not. It's 10 meters per second down here in the bottom. It's 10 meters per second up here, so there is no acceleration. Both cars have a constant velocity. So acceleration is 0, and acceleration is 0. And if I wanted to put a unit on there, it would be meters per second squared. Okay. Second piece, what's happening for both cars at 4 seconds in terms of displacement, velocity, and acceleration? All right, so let's take a look now at 4 seconds. So time of 4 seconds is right here. And that would indicate right up here, I'm looking at this point right in here. Okay, so for this point right there, I am going to see in terms of displacement, it looks like the black and the blue car are both in the same location. They are both at 30 meters right there. So both cars are at 30 meters. I'll start by, oh, clear that. Boom. No, mouse, please. Okay. So for displacement, both cars are at 30 meters at 30 meters. For the velocity, now I'm looking at the slope. So in this case, right at 4 seconds, the black car is flat. It's 30 at 3, it's 30 at 4, it's 30 at 5. So since it doesn't go anywhere, I would say its velocity is 0. It has no change, and that's for the black car. The blue car is still on the same slope, so it's still going 10 meters per second. So on here, the blue car is still going 10 meters per second. The black car is now going 0 meters per second. And then in terms of acceleration, the blue car is going 10, and then right after it's going 10, so it's not changing velocity. The black car is going 0, and then after it's going 0, it's not changing velocity either. Both of them still have 0 acceleration. So still no acceleration, no change of their velocities. And then what about at 6 seconds in terms of displacement, velocity, and acceleration? So at 6 seconds, now I'm all the way out here. So now I'm here. I'm going to pay attention to that point and that point. So the blue car, its displacement is now at 35 meters, right there. The black car is still down here at 30 meters. So the blue car has gone past the black car by 5 meters. But both of them have horizontal displacement, so they're not going anywhere. They're both stopped still. No velocity, no acceleration. So now I'll come back in here and show displacement for the blue car is now 35 meters. The black car is at 30 meters, and then the velocity is 0 and 0. Acceleration is 0 and 0. And again, for units, if I wanted to, it'd be meters per second and meters per second squared. So part D, what would happen if the blue car and the black car were in the same lane on the same road? When would it happen? Okay, so if they're in the same lane on the same road, it looks, based off this graph, that the blue car and the blue car starts behind by 10 meters. The black car they're both going the same speed, and then the black car comes to a stop. The blue car keeps going, and right here, they're occupying the exact same space. So if they were in the same lane on the same road, they can't occupy the same space. Either the blue car jumped up and over the black car, which seems unlikely, or more realistically, the blue car rear-ended the black car, right? The blue car must have hit it and hit it from the back, and it looks like that happened right at 4 seconds. So I know that they can't be in the same lane on the same road because the blue car was able to pass through the black car or past the black car by 5 meters. So in here, what would happen? The blue car would rear end the black car. Oops. And that means it would crash into its back at 4 seconds. All right, so now we're going to look at another slide and do the same thing, just looking at velocity and acceleration. So now we're going to shift on to slide 53, the cop and the speeder. Okay, so I have two cars again, a police car and a speeding car. And now note that this graph is showing velocity versus time. So now these are speeds, and it even gives you the helpful hint that this is not the point where the policeman catches up with the speeder. It's just the time where they're going at the same velocity. So these do not show where they are. They just show how fast they're going. So let's take a look at what questions were being asked for. What's happening in the first second of the graph in terms of velocity and in terms of acceleration? So for velocity, we're looking at the first second, and in that first second, the speeding car is going at 30 meters per second, and the police car, starting from 0, is speeding up to 10 meters per second. So this looks like the police car starts from a rest and then speeds up to 10 meters per second. The speeding car is going 30 meters per second the entire time. So the police car goes from 0 meters per second to 10 meters per second in the first second. The speeding car is constant at 30 meters per second. Okay, now in terms of acceleration, well, I kind of answered that in my velocities. I go from 0 to 10 in 1 second. So that would be a change of 10 meters per second divided by 1 second, which is how long it took to happen. So 10 divided by 1 is 10 meters per second squared. Now my speeding car, it's constant since it's 30 meters per second and it's not changing. That would be 0 acceleration, or 0 meters per second squared. Okay, at 3 seconds in terms of velocity and acceleration, let's take a look there. At 3 seconds, they both have the same velocity. They have the same point there, and that's at 30 meters per second. So I'm going to put in for velocity, it's both the same. 30 meters per second and 30 meters per second. Great. And then in terms of acceleration at that point, let's see, the speeding car is still going 30 meters per second, but the police car has the same acceleration as before. It's going up by 10 meters per second every second. So if I go over from 2 to 3, that's a 1 second difference, and it goes up from 20 to 30, so that's 10 meters per second every second. So the speeding car, or sorry, the police car has a positive acceleration of 10 meters per second squared. The speeding car still has 0 acceleration. And then how about at 6 seconds in terms of velocity and in terms of acceleration? So at 6 seconds is right down at the over here. The speeding car continues going 30 meters per second. It goes 30 meters per second the entire time. The police car is now going 40 meters per second. So it has now gone faster than the speeding car. Police car is going 40 meters per second. The speeding car is going 30 meters per second. And now they're both at 0 acceleration because both of them have flat lines for their change of velocity. right? You'll see that neither one has changing velocity. It's now a constant velocity for the police car and a constant velocity for the speeding car. All right. Ooh, which car is ahead? Will the other car ever catch it? Okay, so which car is ahead? This one's a little bit tricky, but since the speeding car was going faster at the beginning, it should start ahead, right? It should be ahead based off of it going fastest in that first second. In the first second, it's going 30 meters per second for 1 second, where the police car is going from 0 to 10 meters per second for that first second. The police car will only go 5 meters in the first second, but the speeding car will have gone 30 meters. So the speeding car starts ahead. Will the other car ever catch it? Well, now the police car is going 40 meters per second, and the speeding car is only going 30 meters per second. So if the police car is going faster, eventually the police car will catch up to the speeding car, and we could figure that out by taking the area under the curve for each one. So if I took the area under the speeding car curve and the area under the police car curve, they will eventually be equal to each other. And I think that happens at 8 seconds. So in terms of which car is ahead, the speeding car is ahead, at first because it travels 30 meters in the first second, while the police car only travels 5 meters in the first second. The police car will eventually catch the speeder because its final speed is 40 meters per second, which is faster than the speeder at 30 meters per second. Great. Okay, so that is graph analysis for velocity, acceleration, and distance. And now our last piece is getting into doing some forces. So we're going to do these forces in our very last section, forces and momentum. And we're going to come back for part 3 of this video at that point. All right, see you in a couple seconds.